like in every high risk, high gain project, you really don't know fully whether it will work. And that is the excitement.
When it really began 4 years ago, the project was basically something like a Mars mission, high risk and full of ideas that we didn't really know whether we could materialize them.
Why there were so many things that we thought we knew and instead we didn't.
We had a really great team. So we had people who were acoustic side, we had people who were good building the hardware, we had people who were doing interaction and perception. So without that team of complementary skills, we couldn't have got as far as we did. This wasn't a project that could be solved by just one discipline. It was a cross-disciplinary project.
When we got to meet together in person, those meetings were very fruitful, just bouncing off ideas. And I really liked the enthusiasm and the drive of all the people in the project.
So this was my first EU-funded FED projects that I really got my teeth into, and I'm fortunate to have experienced it from start to finish. In just 4 years, I've been able to see how a 20-page project plan document basically planted an idea and how that idea became a vision, and kind of a lot of people put their backs into it, their brains into it, and spent many engineering days after to materialize that vision into what we have today, which is this really impressive, almost magical interactive display.
So we've taken the basic principle of acoustic levitation, which has been advanced through acoustics and physics research in recent years, and we've taken that as human-computer interaction researchers and just tried to figure out how we could use this to build the computer of the future.
We're essentially taking large amounts of ultrasonic loudspeakers that produce a very high intensity sound field that is of a frequency that is not possible to hear for humans. So you cannot see it, you cannot hear it, you can't notice that it's there, but there's a strong physical effect caused by this field, and that's what makes the technology so magical.
It's a very kind of a magical feeling when all of a sudden they see that content in front of their eyes. They don't really understand what's going on. How is that even possible?
The groundbreaking part is, of course, the magic behind levitation. You don't see anything, you don't hear anything, but still there's a very strong force that is created, and that is so strong that particles can even fly.
And by controlling those sound waves, we can control the position of those objects in real time. We can move them in 3 dimensions, we can create pressure fields that can support multiple objects together, and that's how we build up this 3D content in midair.
We really turned science fiction into science fact.
At the start, I had absolutely no idea how difficult that would be and what sort of challenges we would need to overcome. But a lot of potential, and I was really excited to start seeing what can we use this for? What can we do with it? And how can we push those boundaries over the next 4 years of that project?
In the 1960s, you could have 1 pixel on the screen, and people thought, "Whoa, that's amazing!" But now you can have 1 million. So maybe the same for our levitation. Now we can do a smaller number of pixels. We can do 10 pixels relatively easily, but scaling that up to thousands or more to create these really realistic looking objects.
I think that in the next 5, maybe even 10 years, if I really look far enough, we will see this kind of technology take many different forms. So not just big displays, but also smaller ones, potentially being mobile and integrated in many different applications that will shape the way that we think of computers, interactive systems, and displays in general.
We get a lot of Harry Potter references, so I would say science meets magic.